G'day Bifrosters. So let's take the next step in this one, where we're going to actually start laying out our controls, and we're going to talk about setting up the instances. So I don't need this anymore. First thing I want to do, actually I did need that. Let's get that back. First thing I want to do is I want to hook up the curves and the instances. So let's just really quickly, not worry about this for now, really quickly we'll create some instances. This curve in goes to curve points, and immediately it breaks because it wants one curve. So we have our first control. What I'm going to do is start a new input to keep our controls separate from the stuff we're bringing in. And let's just rename this to curve selection. And this will enable us to select any curve out of this array. And remember, we're doing this in Maya as well, so let's just select that. You can see curve selection here. It's not really going to show us much at the moment, but we're now able to change that however we like. So for now, we'll leave that at 0. And then we want our instance meshes to go into instance meshes, and let's make a new output. Or let's not. Let's use this one. Pop out our instances, and there we go. Remember, this curve had a bump in it. We can show that. So this is just literally nothing else but straight up instancing onto our path, which is great. That's working well so far. I'd want to change that to random, and I'd want to probably play with the probability curve, but for now we have some more control stuff to set up before we do anything else. So one of the biggest problems here is that if I select the Bifröst and I go past, I think 2, we've got nothing. If I go below 0, we've got nothing. In the interests of helping people run a good interface, and that's something you should always be thinking about when you're building up stuff that you're especially going to hand off. Let's put in a little bit of a selection control into here. So we'll make a compound. Inside this compound, I'm going to, I need to put one more thing into it yet. What I need is the array size. Let's try and keep this tidy. So let's put the curve in here. Get array size here. So we now have the size of the array of curves coming in. So this means we can add curves to it at any time we like, and this will just keep track of it. What I want to do first is I want to decrement that by 1. Because the size of the array, in this case the size is 3, but we start at 0, so the last item, which is what I'm after, is 2. If I change that to 3, which is the size of the array, everything disappears. So this is going to give me the index of the last item in the array. Yeah? I'm also going to need a value, and I'm going to need that value to be a long integer, like so. And that value is going to be 0. So now we're just going to build a little bit of selection control here. So we're going to take the curve selection that the user chooses, and I'm going to say greater or equal. So if it's, I can't, yeah, that's a good point, I can do that. So if it's greater or equal than the array size, which means greater or equal than 3 in this case, so this will still work. Or less. So if it's less than 0, we need to do, let's kill that for now, we probably don't actually need it for now. What this is going to do is if this selection is greater than or equal to the length of the array, alright, false, it's fine. We'll just take the curve selection. True, we did need the decrement. I knew there was something we needed it for. If it's true, I just want it to be the last value in the array, which is the size minus 1. And the same here, if it's less than 0, so I'm happy for it to be 0. 0 is the first case. So if it's not less than 0, I'll get it to check if it's greater than the amount. But if it is less than 0, let's just make it 0. Output that. Rename this to selection control. And then we'll plug this into our get from array. So now, if I select the curve selection, even if it goes below 0, it's just going to always select 0. And the same, if it goes above 2, above the length of the array, it's going to be the length of the array. And this just protects our users and ourselves, because Bifröst is still a little crashy. So let's just rename these real quick to inputs and controls. So what now? So this has got our instances working. Before we get started on the strands, is there anything else we need to do with the instances? And I'm not sure that there is. Really, this is the heart of the entire rig. I think what we need to do first is get the strands working in between each one so that they are turning up as single strands. So let's work on that now. So the first thing we're going to do is just a little bit of housekeeping. What I'm going to do is I'm going to put all of these guys into an array. Now, if I'd thought about this, I would have done the same thing as I've done for these two and just set it up as an array, but I didn't, and we're halfway through building it, so we'll do the next best thing. We'll just pop this into an array, like so. So now we have a attachment point array. That can just sit there for now, being happy once we get to it. The first thing we're going to implement is rotation. So to make that a little bit easier to deal with, I'm just going to take, yes, that one. I'm just going to take the curve we're working in, and because I'm going to need to see the rotations going on here, I will just move these around a bit just so we can make sure we've got some rotations going on. We can always flatten them out again later. I might lift that one up for the same reason, and that one can go out there, and this one can go out there, and you get the idea. I'm just trying to get a bit less of a dead straight line so that I can make sure the rotations are working. So how do we rotate instances on a curve? Well, if you've seen my copy to points video, you'll know it's got something to do with quaternons and sometimes normals. But what's really, really nice about the strands is we can get all of that for free. There are nodes to do it. We don't have to worry about any of the nasty vector math or cosines or quaternions. Well, we do have to worry about quaternions a bit. Quaternions. Let's not start that again. So we have a node that'll help, and it's called Update Strands Basis. And what Update Strands Basis does is it takes the strand, in this case the curve that we've got from our array, and it gives you the point tangent, point normal, and point binormal of that curve, and it updates that for you, and then puts it out. It basically adds it to the strands. Right, now I've just popped that in the wrong place. That's got to go from the strands, not the instances. Just a little bit of forethought there. So we'll pop that into there now. So we'll make a new branch. And then another node that will really help is strands basis to orientation. That's the one. So now we can pop that into there, and what we've got is this node calculating the strands basis, and this node calculating the orientation. So now, if we pop this out, we lose all of our instances because I put out the wrong thing again. I'm just not really with it today. Let's pop this out here so we get a better idea. Let's replace the points coming in with this one, and you can see immediately all of our telephone poles are now rotated along the tangent of the curve, including the ones going up and down. So that's not going to be working for us for a little while. So let's just flatten these control verts out. Behind it, reshow the Bifröst. So now we're a long way towards where we're needing to go. And what this is really nice for, I mean, we're going to edit this node in, well, maybe not quite in a second, we'll come back to it, but we're going to edit this to add the ability to have random rotations. Okay, but for now we're just getting the instances in and working, and the really nice thing is that this puts out the quaternons for you for the points, which is brilliant, because now, even though we've got our instances all happening and stuff, we want to do things to the position of the points and the rotation of the points. So the next thing we'll stick in before we get to the instances here is resample strands. And this is what's going to allow us to change the number of poles along our strand. Yeah, you see it's suddenly created an awful lot of poles. It's not really what we want, and that's because spatial resample is on. We don't want spatial resample. Right now we have 100 poles. Let's get that down to a bit more of a manageable number, like 12. And the thing about having a lot of poles is you can see our curve is not that smooth. You're getting chunks there and all of that kind of thing. So while our strand is nice and resampled, the underlying curve under it is really just, if we were to change the curve smoothness, which it's not letting me do right now, but basically it's trying to follow the control points of the curve coming in. And so the way to fix that is completely independent of the rig. Resample this curve, or rebuild this curve. So let's rebuild that. And it's got 12 at the moment. Let's take it up to 96, just so it's nice and smooth, and apply it. And you can see the telephone poles just jump straight to the curve. So having a heavy curve is not really going to hurt us, because now we can resample this, go back to 12, and you can see that they're absolutely locked. So what I'm going to do now is I'm going to build the master strand. After the resample strands, I need a couple of bits of data coming through. And what I need is essentially the orientation, so the quaternon that controls which way they're pointing. And I need the position. So from here I can just get point position, which is probably in here somewhere. There we are. And that's going to be our positions. And this is going to be the quaternons that that we are going to be rotating everything by from this point forward. I'm just going to throw down a compound like this. I'm going to put the position in and rename it. And then I'm going to put the orientation in there. And this is how I get everything to behave itself, is I take my attachment points and I put them on each instance with the same offset as they have from the instance itself. So because my instances, if I, oops, I did not mean to do that. If I turn my, let's just turn my instances on. I was very, very careful when I set things up to instance everything at the origin, 0, 0, 0. So if you were to look at one of these attachment points in the attribute editor, you've got these translations here. If I take those translations, so 1.3, 11.5, 0.26, and I add them, or I rotate them and then add them to every single point along this position, I will get these attachment points in exactly the same relative position as they are on the instance, which means that I will get this point value for each of these in the same position along the instance. So let's have a crack at that, and maybe I can show you what I mean. So this is going to be the beginning of our wires. What I'm going to do, instead of just a compound like I thought, I am going to loop through each one. So we need a for each loop like this, and we need to get this array, your attachment point array that we forgot to do, that I forgot to do. Take some responsibility. We need the positions of the instances and the rotations of the instances, so we also don't need that. It's just instance position there, and instance quat there. So let's jump in. We're going to loop through the array. of our attachment points. So this is going to do it however many attachment points we have, and the last thing we'll do today is set up the ability to change those attachment points. First thing I need to do is get the scale rotation translate of this, because I'm going to use the translate here. Rotate by quat. Translation becomes the vector, because remember they're all offset by the same amount as they are on the instance. So it's going to rotate that vector. So that's the vector between here and here. That way when this rotates, this vector will rotate the same way, and anything we use to attach, which we're going to be doing in a minute, we'll be attaching our wires to this, will rotate with them, which is how I can get my wires to stick on the curve no matter what happens. So I need the quat here, and that goes in there. And then what I'm going to do is, and this is the bit where all of the offsetting happens, I'm going to add these to the positions. So what this loop does is it sets up the correct positions for these. It has the added benefit of adding this to however many of these positions there are, right? Because it's rotating them. It's in a loop, it's going through the array of attachment points, in this case there's 4 of them, so it's going through, there's 4 of those. It's going through this 4 times, but every time it goes through one, it then rotates it by all of the quaternons in this, which means that if I change my instance count to 70, it's going to go through and add and rotate this vector 70 times by each one. So this gets us, what comes out the end here is an array of attachment points, positions, that we can now turn into our wires, which we will do in just a second. So for each attachment. So now what we need to do is take this great big long list of points and split it into groups of 2 points, a start point and an end point for a strand, and these will become our wires. Alright, so the way we're going to do that is with another for each loop, but this time I'm going to put it inside a compound. And this is really for no other reason than to keep things organized in my own mind. Inside here, I'm going to put for each. And this way I can look at this from the outside without worrying too much about what's going on. So the first thing we need to do is get the array size here. So this is just everything in this array. And then I'm going to take one off it. It's going to give me the indexes of things in the array, but I don't want the last point anyway. This will become a bit more clear later. So now I'm going to drop down a sequence array, and because we're working with the indices, these need to be longs. So the size is this array minus 1, because this is going to make a sequence of everything up to this array minus 1, which is every index. I'm going to start at 0 and step by 1. So this is now a sequence array that starts at 0 and goes 1, 2, 3, 4, all the way up to this number here. And then we build another sequence array. And again, that needs to be a value of long. And this is the size of 2. And what we're doing is we're going to start that array at each one. So remember, this was 0, 1, 2, 3, 4, which, you know, corresponds to the attachment point 0, 1, 2, 3, 4, 5, blah, 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 blah. Right? We're going to start that one at 2. Well, no, sorry. We're going to start that one at wherever it is in that sequence. And it's going to be of size 2. Our step will just be 1. So what we'll end up with, when this is at 0 position, the first one, this will spit out 0, 1. This is at the first position, 0, 1, 2. This will be building our strand offset for us. So we'll take our output here, and we're going to do a get from array. So these are the point positions after they've been rotated. This is going to get pairs of points from this, and then we're going to output this. So we'll call this point pairs. And then we hook that up to the output. And this is our next thing completed. So what we've done is we've gone through each attachment point, done our rotations on the translate point of that. So we're rotating the offsets and then adding them to the instance position. This gives us our offsets plus rotations for everything along the line, which the rotations do not appear to be playing well at the moment. Which is kind of interesting. That's because I put it very much in the wrong place. So this guy needs to come pretty much all the way back here and be one of the first things we do. So essentially it needs to come straight in from this input, be resampled into whatever we want, and then pop back out again. And there you can see, because we resampled early, it's retained its rotations. Just ignore that one, that's the instances. We'll just hide that for now, just to keep things less confusing. So now they're rotated properly. And we can make another control now as well. We can, from here, make the control that tells us how many poles we want. So we're going to go back and rename and organize all of this later. Let's just select our Bifröst graph. They've all disappeared because our instance count is 0. Let's take that to 16. Now this is something that we have to do another control on, because this is fine, it's all fine until we get too low. And if we get too low to support a curve, and this strand essentially I think is a linear curve, don't quote me on that, I'll have to check that out. But if we get too low to support this curve, at least on my machine, Maya craps the bed and crashes. So I'm going to make another selection control to do this. It's going to be really similar to this, so let's just do a compound. And I'm doing this, I'm breaking the flow of this and doing this right now, because if I don't, I'll forget, and this is important, because I don't want crashes. Instance control. And we'll get this in here. We're just going to do pretty much the same thing. This is already coming in as a number, and we just need to set a minimum number for it. So if we're like less, and I have found that 3 is a very good number. And this is just if it is less than 3. So if it's not less than 3, it's all good to do as it is. If it is less than 3, make it 3. And then output it. That's all we're doing. I can, if I want to be a little bit more well laid out, I can do that. So all this is saying is there's an instance count coming in from the user, so from the interface, here it is. If it is less than 3, make it 3. If it is more than 3, just go ahead and do what you want. And what that saves us from, wow, goodness me, it worked. Oh, I haven't hooked it up. What this saves it from, it essentially breaking on us. Now, I just absolutely showed you that 2 worked. That surprised me. I'm really glad it did, because there's no crash. I'm just wondering if maybe you're trying to set up a 0 instance, then Maya decides that it's no longer happy to live in that world, in a world where there are 0 instances on a curve, and basically decides to drop out. But anyway, it's in now, and that goes into our constant count for our resample. So we now have another control where we can really easily control the number of poles, fences, whatever it is you're putting on here, because this works for a lot of things. And it won't go below 3. 3 is the minimum it'll let you have. Feel free to experiment and change it yourself. Everybody's happy. Let's go back to getting wires working. So we've got our attachment points and our translations changed and rotated, and we've split them into wires. Now it's time to construct our strands. goes in there. And we can put this out to an output to see if it's working. And it's not, it's just flashing and dying. The reason for that is if you look down the bottom there, you can see it's a nested array. So the way to fix that, of course, is to flatten nested array. Let's flatten the nested array, and let's take a look at what these are doing. And there we are, we have power lines that are rotated by the attachment points. So this is, you know, I'm setting up the basic stuff first before we go ahead and work on the sag. That'll be in a different episode, and getting the interface all sorted out will be its own episode as well. This is where I wanted to get us to today. We now have two controls. We can select which curve we want. We can change that, and you can see that everything just jumps to that curve. Everything follows along. So this is the main engine of getting the wires to work. I'm going to do one more control, and that's going to be it for this one, and then we'll carry on in the next one. The second control we set up is the number of instances on the curve, which you can see. So let's switch back to the more interesting curve. But you can see that the instances here are really happy to be controlled this way. All the rotations are working because we're rotating our offsets for our attachment points. And yeah, this is all doing nice things. So the only other control I wanted to put in for now is how many wires we've got. And I'm doing that by essentially I'm going to split up this array. So I'm basically going to say, how many of these are you sending in? And we do that with a slice array. So let's slice the array like that. And it immediately broke, because if we look at our slice array, it starts at 0 and it stops at 0. So there's nothing there. If we stop it at 1, we'll get 1 wire. 2, and you can see where this is going. So this becomes our number of wire control, yeah? And all we got to do is plug in the stop into here, give it a rename, and we've now got a third control. Now you can make that 25 if you like. It's not going to do anything more than 4. You can make it -2, -13 in this case, and it's not going to do anything at all. You can, of course, go and put limits on that control. It's working, and that's always the best thing. So let's just do a quick check of everything still obeys the curve. See, the curve has got a lot of points in it now because we gave it a bit of a reshuffle. I'm going to rebuild that curve because by adding our resample strands at the beginning where it should have been, should actually allow us to have many less points in this curve. So let's rebuild that, and I'm just going to go back to 16. No, 16 is fine. Let's go to 12. Rebuild. Changes a little bit, and it does unfortunately not quite look as good, so we have to work on that in the polish. Let's go back to that. But just as a test, I'll grab all of these and I'll shift them that way, and that's all working nicely. Give them a bit of a rotate. That's still working nicely too. So you can absolutely still control your curve. I will just work on getting the resolution of it sorted out and see if I can make that work better. But for now, that's all we're going to do with this one. What we did is that quite a lot actually, we got our attachment points rotating with our instances. We then turned that into strands for each one. So just remember, it makes pairs of points all the way along and makes a strand out of it. We've got the rotation in based on the curve. We don't have any control over that yet. We'll be adding that later. And yeah, we've got some power lines. We've got the attachment points in exactly the same place as we put our, you see, we put our locators to start with. Don't forget too that when these are rendered by Arnold, at least when the strands are rendered by Arnold, they're rendered as curves, so you have to keep that in mind and be careful with what you're doing. But this is enough to show us the strands are working, and in the next one we'll start adding some value, I guess. We'll add things like the sag, the amount of sag, some more curve controls so that we can actually adjust this curve without horrible amounts of pain, and many other controls, because right now we've just got these. We want more. Alright, so I hope that's helped and hope that's provided some insight. Thank you very much. I'll see you in the next one.